We are able to define a proprietary for them, artificial intelligence model that identifies, for example, defects or classifies good objects with respect to bad objects. We are also using now a polarized sensor that basically is also able, we use it both for traffic applications and we can use it also for industrial applications. For example, for traffic application, we used to remove reflections from windscreen.
In particular for computer vision application, it is practically mandatory to process the data on the edge because, for example, one 5 megapixel sensor can produce a few hundreds of megabytes per second of data that cannot be sent somewhere in the cloud due to limitation of the network.
Welcome to Avnet Silica's We Talk IoT. We'll chat with innovators, experts and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth-Hader. Ski resorts lose millions to ticket fraud each year. Traffic authorities struggle to monitor vehicle occupancy, and industrial manufacturers miss critical defects that human eyes cannot detect. What connects these challenges? The need for intelligent vision systems that work in real time. And my guests today tackle these problems with AI-powered cameras that process video on the edge. Tommaso Scuccato and Marco Bergamin from Videam bring backgrounds in aerospace and automotive engineering to create smart vision solutions. Their patented algorithms run directly on cameras, eliminating the need to transfer sensitive video data to the cloud. So from ski passes to smart cities, their technology demonstrates how edge AI changes what machines can see. I'm really excited to have you two on the show today. Welcome. And I would like to give you the opportunity, of course, to introduce yourself. Tommaso, Marco, tell us about yourself and what it is you do at Videam.
Thank you so much for the introduction. I'm Tommaso Scuccato, one of the co-founders of Videam, that is a startup specialized in artificial intelligence and computer vision solutions. As it was anticipated, we basically have many solutions in different aspects, starting from ski resorts to smart cities, in which we can tackle using AI real-world problems.
Yes, I'm Marco Bergamin. I've been working in Videam for 2 years, almost since when it was founded. I'm basically an embedded system engineer. So I have experiences in many fields like in automotive, telecommunication, and also in the industry because I have a past, an history also as a PLC software developer. And now I'm working here in Videam integrating AI in embedded devices.
As we can basically start a bit from the ski resorts, that maybe it's the strangest solutions that we have up to now. Basically, what happens, ski resorts sell tickets, ski tickets to users, and these ski tickets are personal. So basically, you should not transfer these ski tickets to multiple users. If you buy a seasonal ticket, you're supposed to use it from the beginning to the end of the season. If you don't go to the mountains one weekend, you cannot borrow to your brother or your cousin.
Sure. So you cannot share it, right? That you give it to another person and then they ski on your pass.
No, This is not allowed. But it's an issue that it's really frequent in the domain, and it's not easy to tackle because resorts have multiple points of access. There are multiple lifts. They are spread around, and also users like operators of the resorts and of the lifts have much more important stuff to do, like safety stuff to do, like checking that kids sit well in the lifts and this stuff. So they do not have the time to check if basically who is skiing is actually the owner of the ski pass. And this is what we try to tackle. We know the issue. I'm a ski instructor, so I know this topic from the really beginning. Many years before, basically, there were the technology to solve it in a clever way. And we patented an algorithm that basically using cameras, every time a user passed through the gates where they scan their ticket, a picture is taken of the full body. So a low resolution picture of all the person, all the skier that is passing through. So we do not focus on any biometrical data, so no facial recognition. Also because in the ski domain it's not possible because users have goggles, have face covers. Sometimes it's foggy. So basically you cannot focus on details of the person appearance. So using these basically full body images, we are able to check. We link all the pictures of the skiers during all the passages through the gates. We link these images to their ticket, and we basically check if the overall aspect of the person remains stable during the usage of the ticket. And we alert backend validators when we suspect a fraud. So they can take actions remotely, so not at minus 10 degrees in the slope, but like in a cozy office, and they can decide what to do. And this solution, it's really spread now, because after just 2 years, the past winter, we monitored resorts in the US, in Canada, in Spain, of course in Italy, in Austria, Czech Republic. And also during past summer, we also covered the southern hemisphere because we had an installation in Argentina as well.
Terrific. So, and when you founded the company, was that the problem you were trying to solve, focusing on the ski ticket fraud, or what problem did you have in mind when you started the company?
When we started, actually, we had in mind to basically develop vision solutions using AI. And we understood that to be able to tackle really complex problem, because that is where we wanted to go as a company, we needed a solution, a hardware solution that was basically proprietary. So we would be able to deeply customize it. That is the first driver of the company when it was founded. But actually, after just, let's say, a few months, we had this idea in mind. So we started more or less like a game. So we proposed a patent, we proposed to customers, and actually this thing drove really, really fast because everyone was really interested in it. The patent went on smoothly. We were able to do some partnership with big companies to promote the solution. And so basically became at first a parallel project, but then we were able also to integrate that project in our smart camera. That was the main objective of the startup itself.
You both come from backgrounds in aerospace and automotive, if I understand it correctly. How did that experience shape your approach to AI vision systems?
I'm a telecommunication engineer. I started at first during the last period of my university, also for a few months after. I was working mainly in radar design and also understanding of radar signals, mainly for planetary observation missions. I also had an internship at JPL in Pasadena. It's a NASA facility where I was involved in the development of a radar sounder that is a particular type of radar. The radar signal goes down below ice and tries to understand if below the ice there is liquid water. Then we moved to navigation satellites. So basically developing and studying new signal designs for mainly Galileo satellites with working with ESA projects. And that basically background helped us first to try to find the best technology and the best products and try to design it really with, let's say, in a really clever and precise way. So not to have issues when we have many devices out. So basically with that in mind.
In my case is quite different because I started with computer vision when during my master thesis. And then during my very first job, I developed an application based on computer vision to do quality checks on inside a machine that was producing special cables for example, aerospace applications. So there was these very tiny cables with many layers. During each step of the production, there was a camera with an algorithm that was checking that some parameters were within a given range, for example. But it was about almost 10 years ago, was, let's say, classical computer vision because the AI was not yet a thing like it is now. My experience with an automotive were also useful for designing embedded devices for Internet of Things, but they were not very related to AI. Let's say that I had to study it almost from scratch in the last 2-3 years.
So you have patented your algorithm, and you mentioned that you don't use facial features for detection. So how does it work?
For that particular topic, we look mainly high-level features that are not unique to a person. So basically height, body shapes, mainly color patterns of suits, because basically for that particular domain, that is ski resorts, usually users don't have multiple ski suits. So usually they have a few, and we were able to tackle this problem linking to a ticket ID, let's say, one or many profiles of the skier. So for example, to give an example, a practical one, when I teach ski, I have my ski instructor suit. When I go skiing on myself, I have another suit. So in my case, basically, if the algorithm propose my figure and my ticket as a potential person that swapped the ticket, just with a simple button, the operator is able to say, no, algorithm, look that this ticket ID is linked to a user that have two suits. So basically, now it is in the system, and anytime I use any of the two suits, I will not be notified anymore. So yeah, that it's a logic that we patented and we tested in the field, and it's really powerful.
Yeah, it's really cool when you never, of course, think about it. When you talk about facial recognition, that obviously in a skiing context, you already have the issue. If it's a sunny day, the person wears sunglasses. If it's really snowy, he wears the big goggles, and then it completely changes the whole image, right?
Exactly.
Yeah,
So
really
we basically do not look at these features because actually they are not meaningful to distinguish between people. We look at features that in the context don't change often.
You decided to process AI on the edge rather than in the cloud. Why did you do that?
Basically, this solution of processing AI on the edge has many advantages. First, security. For example, smart city and let's say license plate detection recognition. There are the final users that do not want to basically upload images or videos in the cloud of let's say third-party systems because you cannot have the certainty of these data do not train some algorithm without knowing. So basically having the processing all inside the camera and notifying only the events, the final events, solves this issue. Then there are many other issues like, let's say, responsiveness. We can do AI in real time. For example, in our smart camera for traffic application, we have many algorithms that runs in parallel. We have object detection algorithm, we have classification algorithms, we have OCR algorithms that all run real time. The slowest one runs at approximately 100 frames per second. So we can basically immediately produce data events. We have also a cloud solution, let's say, that can be installed in a cloud or on-prem of the users that collects all this data in their servers, and we integrate it also with their systems. For example, if they have some internal databases where they have a list of, let's say, blacklist plates, we can, on the fly, as soon as the event of, for example, staying on the traffic domain of a new plate being created, we can immediately check, connecting to their systems, if this is a blacklist, if the plate is in the blacklist or not. And we can produce complex solutions and notifications based on all these aspects. So this, and another aspect is the cloud. It's really also energy greedy, so we are able also to perform everything with a few watts of power. So there are many advantages in our solution. Also, traffic consumption, of course, sending event of the small string of the plate being read instead of sending all the video stream. It's much more cheap on, let's say, data transfer side.
I would also say that in particular for computer vision application, it is practically mandatory to process the data on the edge because, for example, one 5 megapixel sensor can produce a few hundreds of megabytes per second of data that cannot be sent somewhere in the cloud due to limitation of the network. For this reason, we are seeing every year new processor that can process more efficiently the data from the cameras using NPU, neural processing unit, that can consume like in some cases also less than 1 watt. With the cloud architecture, you can do something, but on single pictures, not on videos, in my opinion.
We will take a short break. Stay with us. We will be hearing from our guests very shortly. This podcast is brought to you by Avnet Silica, the engineers of evolution. We help you bring secure, intelligent, and connected products to market. If you want to learn more about us, we have put information and links in this episode's show notes, and you can also connect with us on LinkedIn or avnet-silica.com. That's avnet-silica.com.
What limitations of existing camera systems did you encounter? Why did you choose to build your own?
Well, we wanted to have the maximum flexibility because at the beginning we had many ideas and we wanted to be sure that we could do everything with the hardware. So we wanted to develop our hardware based on our requirement. And for this reason, we choose a platform from AMD, which is the Cria K26 system on module, which is basically a system on chip with an FPGA. This gives us the possibility to implement our ESP, the little unit that are able to process the raw data from the camera sensor. Also, we use it for accelerating some algorithm, for example, the AI algorithm, and give us also the possibility to implement very, very fast tasks. For example, me and Tommaso, we have a background in the GNSS industry. So we put also a GNSS module in our camera. We implement an hardware feature to connect the PPS out of the module that gives us the time synchronization very accurate to the input trigger of our sensor module. This can allow us, for example, to synchronize perfectly different cameras. Also to implement some, for example, stereo vision algorithm technique on different cameras that are not physically connected. This is one of the possible features that we could implement with our hardware. We also design it to be, let's say, future-proof because the initial application is related to the traffic. Basically, plate recognition, vehicle classification, and so on. We would like also to enter in the quality control field in the automation sector. So for this reason, we have already implemented some interfaces like, for example, the RS8485, the CAN bus, beside the Ethernet, the standard Ethernet connection. So to be ready also to allow our camera to communicate, for example, with a PLC in a production line and to exchange data. So this is basically the reason why we wanted to have the complete control of our hardware.
We can accept up to 4 video streams with 4 camera modules. So we can also, let's say, check objects if we stick to the industry control from many angles.
Okay.
And basically perform either stereo or, let's say, triggering the capturing of the images from 4 sensors from, let's say, 4 different angles and process all of them in real time in our hardware. And of course, as Marco said, connect to industrial interfaces if we have to put our system in more complex systems of the customers.
Yeah, let's maybe dive into some more use cases. So ski resorts obviously is one very famous and one where you can relate and understand really easily how it works. But I heard from you that it's also possible to use it for traffic control, for maintenance purposes, or for industrial use cases as well. Maybe you can tell us a little bit more.
We can really quickly sit with the customer and understand the issues in their production line that can be solved with vision algorithms. And we are able to define a proprietary for them, artificial intelligence model that identifies, for example, defects or classifies good objects with respect to bad objects, sitting with them and understanding what is good and what is not good for their particular, let's say, industry quality assurance, let's say, internal policies. We usually, for traffic, use global shutter sensors, but we are also using now a polarized sensor that basically is also able, we use it both for traffic applications and we can use it also for industrial applications because in front of each pixel, basically, it has a polarized filter with different degrees of polarizations. So from a single, let's say, capture, you do not have one single image, but you end up with many images, everyone with the different polarization angles. And then we can combine these images in a clever way to identify also defects and aspects that are not visible to naked eyes. For example, for traffic application, we used to remove reflections from windscreen. So we can also perform some inside vehicle applications. For example, there is a big demand in the market for cameras that are able to check if people uses their phone while driving. That now it's one of the most dangerous things that drivers can do. It causes many incidents. So there is a lot of attention from our final customers to that topic. With our solution, we were able to basically tackle this aspect in using this sensor, and we produced basically a camera that is really easy to install, because regardless of the installation, of the hour of the day, you can completely remove the reflection from the windscreen and see in a sharp way also the people inside the car. As I was mentioning, also in industrial, this sensor can be used to identify defects in lenses, in glass production, in plastic production, in industries where basically these additional information coming from images at different polarization angles can be injected in artificial intelligence algorithms to identify features not visible with a normal sensor.
Interesting. Yeah, with the windscreen, the problem was that you could not see inside the car, right? Because once the sun hits the windscreen, a camera would not be able to identify even if there's a person inside. So in the future, there's no more excuses. It wasn't me, or I was just scratching my cheek or something, right?
Yeah, exactly. No, that problem is really complex to solve in a different way. Also because you can use, of course, a polarized filter that you put, like the camera ones, like the professional photography ones, but you have to manually adjust depending on the hour of the day, of the surface that you are framing. But with that particular sensor, we removed all the manual aspects of removing the reflection, and we can do it regardless of the surface that you're framing, regardless of the hour of the day, regardless of the installation. So it's really easy to solve the solution with our product.
And just to rephrase, the polarized sensor works in a way that basically you take multiple pictures and then by putting them all together, just removing the glare. That's how it works? In simple terms?
In simple terms, that's what we do.
Very cool. Very clever idea. Your system also integrates with existing infrastructure. How important is backwards compatibility to your customers?
Actually, we are helping our customer to migrate to cloud solution to aggregate data from heterogeneous devices. We are also able to, for instance, to take the proprietary protocol of a third-party supplier to convert it on the edge using a bridge that we design to enable, for example, a possibility for older devices, other device that doesn't support, for example, MQTT or secure authentication, to communicate securely with MQTT with our new cloud infrastructure. So we can help them to migrate older system to new infrastructure using edge devices.
So we can basically import and augment the capabilities of hundreds of cameras that are already installed.
Wow.
That may be too costly or too complex to change 2 hours. So we can basically start, a customer that wants to install our cameras because of our solutions, they don't have to change all of the systems that they have. But basically we can provide small devices that augment their products to the new solutions that we provide with our camera itself.
Where do you see the biggest opportunities for artificial intelligence vision systems in the next years?
I think that we will see many more smart devices in the near future, because there are many applications and problems that just with, let's say, a clever idea, they can now be solved with a smart camera. For example, the ski industry, if we want to take our solution as an example, it was a lifelong problem. But actually, we were the first ones that solved it with artificial intelligence, and we did it. We did it really well. So there will be many more examples like ours in the futures. So we think that if we are able to provide a platform that can tackle this, the capabilities to solve these problems in a clever way, we expect that in the near future there will be many more devices like this. Mm-hmm. We are also developing a new hardware with different ideas in mind. I don't know, Marco, if you want to explain a bit.
Yes, so we went in last December in a workshop organized by Avnet in Padua, where they presented with ST a new microprocessor with built-in AI accelerator, which was very interesting to us because was powerful enough for our applications. The power consumption was also very low. It doesn't even require a heat sink to dissipate the heat. And it is the new STM32 MP2 system chip. So we were very interested in this application when we, right after the workshop, we tried to buy it. We were able to have the first development kit in the following January. And we started to develop a smaller camera for tailoring application that don't require all the flexibility that can be addressed by a powerful FPGA. But they can do, for example, object detection, object recognition, and other simple tasks. Since we were one of the first, I think, at least in Italy, to use this hardware, we found some software-related bugs in for example, in the Linux kernel, in the proprietary driver, etc. But thanks to Avnet and also ST, we were able to speak directly with the engineering team who developed the board. And in a couple of weeks, we fixed the problems, basically. And now we are proceeding with this development. We are very happy with the support that we received. Even though we are a small startup, we were helped a lot.
Yeah, sounds really cool, and that like you have a lot of new ideas that now can be realized with this new platform, I think. If any of our listeners now has an idea and wants to bring their AI vision system to life, what advice would you have for them?
I think that the first thing is to find a nice development kit, well documented, to read carefully the documentation. First of all, do not be afraid to try it, to propose it to people that could be interested, because you never know. For example, the project related to the ski pass was started, as mentioned before, as a toy, more or less. But when we had the opportunity to try it with some ski resort owner, we understood that it was very, very necessary for them to have a system like this. And within a year, we had already our deal, our partnership.
Basically, I think there are many applications and problems that can be solved with AI and vision aspects. Of course, the biggest issue is knowing these problems. Of course, the issue of the ski pass, it's known only to people of the field, and usually it's not neither easy to know these problems for people who can basically solve the problem in a clever way. So yeah, I think that the link of let's say people with technical background and with like solutions as ours that can solve these problems with the people that actually have problems to solve and they think that can be solved with these solutions, it's really important. So I think it's really good also the work and the job that Avnet is doing in organizing workshops to putting together all the field application engineers that their work of going to customers and their work of linking technology producers and suppliers as us to customers that may have issues but maybe do not have the product to solve it or the let's say background to solve it. I think it's really important and basically it's helpful for everyone, for us, for the final customers, for Avnet itself, so that we can produce thousands of cameras.
Fantastic. Yeah, that's a great summary also for this whole episode. Thank you. If you had to put together a playlist for this episode or for your project or your company, what song would you put on it?
Don't Stop Me Now, Queen.
Very nice.
Do it. I like it.
I don't think we had that yet. Our playlist is growing quite a lot now over the last couple of months. Very nice. Don't Stop Me Now. Very good. Before we close this episode, is there anything you would like to add?
We are also developing a camera enclosure targeting high-level applications and areas where also design is kind of a matter. I have a really close friend of mine that is a product designer, a really good one. He just won Salone del Mobile at Milan. He just won another international trophy in New York. So we said, but why don't you design for us a camera enclosure that it's good, that we can install everywhere. We can install in museums, we can install in the ski slopes, also in really visible places and areas. And basically people, they do not look at that and saying, that camera, why do they put that? It's not beautiful, they ruin the environment. So we are also developing this new, let's say, fully hardware solutions. And to all the people that we are showing it, we are receiving a lot of interest. So I think also, let's say, we will see in the future more and more technical solutions that will have to pay attention also to its design, because we will be filled, I think, in the next years with these devices, and I don't think anyone wants cities to be filled with ugly cameras, and so we are trying to fix also this.
Yes, we want to sell it also to art galleries and as a piece of art.
Exactly.
Functional piece of art.
Terrific. Thank you so much, Tommaso and Marco, for sharing your expertise. It has been super interesting to learn about vision systems and artificial intelligence and the different projects you have already realized. Keep it up. I hope to hear from you again soon and maybe have you again on the show to talk more about use cases and exciting projects you realized. Until then, thank you for listening to We Talk IoT. Until next time, stay curious and keep innovating.
Thank you.
Thank you.
This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.